Hello, so we're going to basically be going through Dr. Chan's workshop number 9, and I'll go ahead and do a quick tutorial on this workshop so that it can be a little bit easier to understand. So anytime that you're given patient-specific information, that trumps anything else in a problem when you're dealing with short infusion. Let's start off with the problem. You're given the case, AP is a 20-year-old male, etc. So from the problem we're given, the physician wants to start AP on no more pastries for an IV on Q12, so that's our interval, and then he wants the concentration to be 27 milligrams per liter, 60 minutes after the end of infusion, okay? And it's telling us to use a short infusion model for this case. So you're given here all the patient's information, and then right here you're given all the patient's trough and the peak information. So we're going to go ahead and start drawing that on the graphs. So basically we administer the dose, okay, and any time that you're given the infusion time, that's going to be the highest peak that you have on the graph, okay? So even though it's not drawn to scale, you will go ahead and draw out the infusion time to be here, okay? That's gonna always be like that for every peak that you have, okay? So in the problem, it tells us that the infusion time is half an hour, okay? So right here, we're given the dose, okay, and then the T infusion time is half an hour. That's where we draw that, okay? Then we have the dose. It says that the dose is given at 6. So if the dose is given at 6, we would just go ahead and put that 6 o'clock right there because that's when dose was given. So you're going to mark that on your graph at the lowest peak. You're going to call this 6 o'clock. And then it was checked, the trough was checked at 5 o'clock, which is an hour before the dose was given. And you are given the concentration to be 10 milligrams per liter to be your concentration, okay? Then we're also given a peak was given at 26 milligrams per liter. You cannot use this 8 o'clock, you can't draw this right next to the 8 o'clock because it's saying it's a peak, right? If you draw it anywhere around here, that's not peak. So basically you have to extrapolate this information and you have to intuitively transfer it onto this side so that we can go ahead and have everything on the same line, which is aka the same slope. And if we have everything on the same slope, then from there we can go ahead and calculate a patient-specific K, correct? Okay, so from here we can go ahead and basically transfer over the infusion time, which is going to be 6 o'clock plus the infusion time, which is going to be 6.5, okay? And then you can also write, around in this area. Now you could put the 8 o'clock, so we'll go ahead and, figure out where 8 o'clock is right around here. So 8 o'clock, and we have it as 26 milligrams per liter. Also, lastly, to figure out when that trough was checked, it says that it was an hour before the dose was given, okay? Since we know our interval is Q12 hours, we can go ahead and add 12 hours to that 6 o'clock because that is our interval from when the dose will be given. Basically, the medication is given BID, okay? So 6 plus 12 is going to be 18, okay? And then now you can intuitively think, because the trough was checked an hour before the dose, if our dose is going to be given at 18 hours, then that means the trough is going to be checked at 17 hours. So we can go ahead and draw 17 here on the graph. And then you can transfer over that 10 milligrams from the first part, which is right here, onto that right here, the hour before. So that will also be considered 10 milligrams per liter. So now we have all that information that was given. Now, instead of having it split up between, two separate boxes, we now have them on the same slope. So now, since all that information is there, we can basically go ahead and calculate a patient-specific K. So let's go ahead and do so accordingly. So let's see. equations, we know that K, let's write it out. What does K equal? K equals ln C1 minus ln C2 all over delta T. So in this situation here, we now have two concentrations along with two times, okay? So a lot of people, what they would do to make the mistake, they would think that a patient-specific K would be, oh, I'm going to do, ln of 26 minus ln of 10, which is correct. But then their delta T is going to be wrong because they're going to use 8 minus 5. And that's not correct because you have those two times that were checked were on different, they weren't on the same slope, right? So what we had done here was put everything on the same slope for now we can calculate the correct delta T. So we have ln of 26 minus ln of 10 all over. We have 17 minus 8. So when you calculate that, your K should now be 0.1061 inverse hour. So that's what your K would now be. Okay? So that makes sense. So you have a K equals ln of C1 minus ln of C2 all over delta T. And then to the, to the right of it, you have everything solved. So now that we have K, that was pretty much the hard part. Everything from here on out should be relatively straightforward. So the doctor wants, for part A, it says calculate a new dose that will achieve the original parameters based on the current levels obtained. So the new dose that the doctor wants is based off of that 27 milligrams per liter, 60 minutes after the end of infusion, okay? So if our infusion is half an hour, which we have that written as 6.5, he wants it an hour after. So that means after infusion time. So you're going to go onto the graph and put an hour after the infusion. So that would be 6.5 plus 60 minutes. Excuse me. So that's going to be 7.5, right? That's what the doctor wants. He wants to know, that's what he wants his peak to be. Okay? 27 milligrams per liter. That's what he wants. Okay? He wants his, and then delta T equals 60 minutes, right? So he wants his, this is our infusion, which is 6.5. An hour later, it's going to be 7.5, and that's what he wants, okay? So we're going to calculate a new dose based off of that information. So when you're using when you're solving for short infusion model, there's three main important equations. They're right here. That the top one is calculating a new dose. Let's see. The first one is calculating a new dose. And the second one is calculating the concentration, aka like your CP max. And then the last one, say, is the CP2, which is Dr. Chan's favorite equations. Okay, so these three equations are very important when solving for short infusion problems. Okay, so for the first problem, basically you're going to do your MD because that's asking for a new dose. Okay, with your target being 27, right? Because that's what the doctor wants. 60 minutes after the end of infusion, that's going to be your T because that's going to be your time, okay? And then your delta T, your T infusion time, that's going to be given. That's always the same T infusion, is going to be 0.5. And then your tau, which is your interval, which is given as 12 in this problem. So when you solve everything, it's going to look like this. So 27 is your target, and then 5.81 is your clearance, which you have to solve for. When you do your clearance, that's basically going to be the your VD times your K. So when you solve, and then you're given the VD is 0.75 per kilogram. So you basically have to solve that, and then you can go ahead and use this problem. And then 0.5 is your T infusion, And then your tau, like I said, was given as 12. And then your T infusion, which is this 0.5, that always stays the same. And then the tricky part is this one right here, but because it's 1 hour after the end of infusion, that's the time that you're using because that's what the doctor wants at this 27 concentration. Okay, so when you solve for everything, exactly it should be 1216.9. But the problem is asking you to round to the nearest 100, and that is 1200 milligrams. So from there, that is your dose that you would give according with everything else. So now when we go into part B, it's asking you calculate the predicted CPSS max 60 minutes after the end of infusion. Again, after the end of infusion, we're going to be right around here, this 7.5, okay? That is where you are looking at on this graph, okay? But he's asking you for a CPSS max. Which equation do you use when you're using CPSS max? You're going to be using that middle equation, right? The long one, okay? So when you plug everything in, what is it asking you? Oh, you're also going to transfer the information that you just solved for in the previous problem, which is the 1200 milligrams, right? Okay. So basically, you go, your dose is 1200, your T infusion has not changed, it's 0.5. Your clearance is 5.81, that has not changed. Your T infusion again 0.5, your tau has not changed, that is 12. And then your your delta T is 1 because it's asking you 60 minutes after the end of infusion. So we're still after that that 7.5. Okay, so when you solve for your CPSS max, you get that 26.62 milligrams per liter. And basically that is telling you that that is what the exact number is after that 1 hour, not 27. So when you calculate it, you're basically going to get that 26.62, which is kind of close to where the doctor wants it, okay? So continuing on, we're going to go to problem number 3, or number C, letter C, which is asking you calculate the predicted CPSS min 30 minutes prior to the next infusion. Okay, this is not going to be at that 7.5 because it's changing its time. Okay, so 30 minutes. So when does he get infused? He gets infused at 18, right? At that 18-hour mark. It's asking you 30 minutes prior to the next infusion. So that's going to be 30 minutes minus the 18. So that's going to be 17.5. Okay. Because it's asking you what is the CPSS min 30 minutes prior to the next infusion. And then we want to know that concentration, okay? We don't know that. We want to know that right there. So let's go ahead and draw that. We want to know that. We don't know that. Okay, CPSS min. Okay, so CPSS min, that's 17.5. So basically what you can do here, you can use Dr. Chan's favorite equation because you already have your CPSS max. All you have to do is now solve for the CP2. When you do that, you have this, okay? So CPSS equals CPSS max e to the negative kt. Your k is still the same, but now your delta t is, you're using 17.5 minus 7.5. And then you're using the 26. The reason why you're using the 7.5 is because for your CPSS max, you're using that 26.6 concentration. So your times and your concentrations have to line up. So when you solved for that 7.5, which is right here, you calculated your CPSS max to be 26.6. So when you're trying to figure out the corresponding CPSS min, you have to use the right times with the right concentrations. Okay, so that 7.5 corresponds with the 26.6, and that 17.55 is going to correspond with your CPSS min. When you solve for everything, you're going to get a CPSS min as 9.21 milligrams per liter. Okay, that is your min concentration that you calculated according to the 17.5 time. Okay, so letter D, it's asking you, the physician is worried that the new dose will still produce toxic levels of no more pastries. The physician wants a trough of 5 milligrams per liter or lower, and with a peak of 25 milligrams per liter. So basically, you have to now calculate a new dose because the doctor is thinking, oh, this is going to cause toxic levels. So if it's going to cause toxic levels, what does that mean? He wants to increase his interval, right? Because if he thinks that that's already too high, we have to administer the medication less frequently. And how do we go about doing that? We have to extend our boundaries. So right now, our interval is going to be every 12 hours. The next logical bet would be to do every 24 hours, not 18, because it's not very compliant for the patient to do it every 18 hours. It's not convenient for the patient or the doctor. So we're going to go ahead and do it to once a day, Q24. So the only things that are going to change here when you're using that wonderful equation for the dose, which is that MD equation. The only things that are going to change is your target, which is your CPSS TAR, and your interval time. Okay, so what you do is you're going to calculate the target's going to be 25, and then everything is the same. Your interval is 24, and your infusion stays the same, and so does the delta T. And then when you calculate everything, you're going to get 1400. So you can now calculate part D, which was your new dose with the new interval. You're not quite sure if you've met the boundaries yet until you calculate what you have in part E. Because the doctor wants you to be no more than 25 milligrams per liter versus 5 milligrams or lower. Okay, so we won't know if we're in target until we do part E. What part E is asking you, calculate the CPSS max 60 minutes after the end of infusion. Again, after the end of infusion is that 7.5, right? Minus 6.5, and then that's your delta T is the 1 hour. So you're going to use that new dose that you calculated from the previous problem, which was 1400. And then your new interval is going to be 24, and then again your delta T still stays 1 hour. So for us to make sure that we are well within the boundaries, we have to go ahead and calculate it and see what our actual CPSS max is. When you do that, it's going to look like this, okay? And then you get your CPSS max of 24.3 milligrams per liter. That is where the doctor wants us. He doesn't want us to be no more than 25. Okay, so that's pretty much everything, and you have solved parts A through E correctly. So have fun practicing the problems. Again, this is going to be what the graph looks like, just in case, just one more time if you want to look at it. So there you go. Good luck and happy PK studying.